Okay, it's roughly October 21st, 2016, talking about the new R01 building on the ALR grant. And the situation is following. In the ALR grant, we have three aims: interferon beta related to B cell tolerance loss, aim 1. Aim 2 is anti-CD20 B cell tolerance loss, also related to interferon beta. Aim 3 is human and interferon, just studying interferon in humans. I think the anti-CD20 treated. Over here, the new grant is different. We're going to take that as a given. In aim 1, interferon beta, we're going to say it causes intrinsic, it somehow is intrinsically high, maybe due to IRF7 and NF-κB, because we have that data unconfocal. And this is in T1 cells, because we have sorted T1 cells that show this. And we're not sure how that works, but we know that's the interferon enhanceosome, and it may be just an intrinsic property of B cells as they come out of the bone marrow that they have this enhanceosome turned on. Well, they can't help but think TLR7 being stimulated somewhere by DNA, but that's something else. But it's not endogenous. It's not intrinsic DNA or RNA signaling. In anti-CD20, we know at 2 weeks causes the problem where at 2 weeks, that's where you need interferon beta. And if you block interferon beta at that time, then cells don't develop. No, if you block interferon beta at that time, autoreactive cells don't develop. And interferon beta knockout, that's when the BD2 starts to get a hit of the beta knockout. You see it most of 2 weeks. Actually, interestingly, at 4 weeks, 6 weeks, it sort of evens out. That's something else to think about. So the new aim is building, the new mouse, or the new grant, will build on aim 1. The key role will be T1 heterogeneity. This is, it's kind of like the title. So heterogeneity at the transitional stage 1 or early stage B cell is already there, and we know this is the case. But there's beta, there's different beta producers, different B cells capable of responding to innate or adaptive pathways. For example, we know down here with the heterogeneity studies that some may be more responsive to BAF receptor signaling, others have higher CD86 and the T cell sort of a focus, T cell CD86, CD69, but anyway, they might be more likely to go to germinal center B cells. So, but we think lupus is a heterogeneous disease. We know that. Certain things influence lupus, BAF, but that doesn't work for everybody. Interferon beta or interferon signature, but that doesn't work for everybody. And maybe hyperactivity of the B cells, maybe T cells even. T cells have a role. And so that might be population cluster 2 over here is driven by the T cells. So we can call that the environment. But the thing is but it'll show up, we think, in the T1 stage, or at least it'll be brought out in the T1 stage. For example, in T cells, you take the T1 B cells, cluster 2 T1 B cells, and they might be sensitive to CD86 signaling, and blockade of CD86 or removal of 86 might take those out. And we have that data with CTLA4 IG. But that's the key. Lupus heterogeneity can be actually represented by studying just a T1 population, both in mouse and in humans. So the first aim will be to build on all this heterogeneity and that fact that interferon beta is a key focus factor at T1 stage. And then we just go through and sort of set up models that we'll use later to show the heterogeneity. For example, using the whole mouse model, we already know what beta knockout does. I guess it's down here that beta knockout take out cluster 1, but cluster 2 and 3 are sort of there. So beta is needed for that versus this is BD2 where they have beta, but I guess they have CD86. We already showed that was high. So we get all the clusters there. But in any event, we'll use the whole mouse, B6 normal, BD2. We have the CD86 knockout. We have the NB4, which lacks IgM signaling. We got the IRF alpha receptor knockout. We put that up there. So we got all these knockout mice. And we have treatments that we actually did with all these mice. For example, CTLA4 blocks CD86, TACI, the block BAF. That didn't seem to do much. And we got anti-beta. So we got treatments and we got mice. And we're gonna just propose that by looking at these mice, they'll really reflect these T1s, will show up in the T1s, and really they'll also reflect the different subpopulations of lupus patients. And aim 2 is now to actually, and I should say aim 1, we're going to have readouts that will be in terms of, I guess it'll be confocal imaging, high resolution confocal imaging, and autoimmunity and so forth. Try to make it look like, we're going to be exploratory. We're going to show that this heterogeneity does exist. And then aim 2 is going to be to actually show the heterogeneity and do that with the single cell analysis, as well as a confocal sorting of T1s, if we can do that, as well as sorting, and this may come up in sorting, I'm just talking a little bit here, sorting of then based on the markers like CD86 and CD69, which is on the cluster, maybe BF. So between sorting the cells and looking inside and also looking at the single cells, we'll figure out that this is indeed the case. And of course, all the models, this is the thing that's a good thing about a grant, all the models you build up here, either knockouts or treatments, you apply here and you can actually see, for example, lack of CD86 will lead to a lack of this T2 cluster, or enhancing T cells, adding T cells or signaling will enhance this. I don't know what IgM signaling will shrink. And then BAF, or BAF blockade, may shrink this cluster. Doesn't seem to be very important in BD2 because, we did that already and it doesn't happen. But it might be important in humans. And that brings up the third aim, which is do the same thing with humans. And again, say that the heterogeneity that's represented in the T1s in humans will be reflected in terms, the heterogeneity in response and so forth, be reflected in terms of heterogeneity of the T1 cells. And there, for the humans, we can say we're going to select humans that are undergoing efalimumab studies, but actually I don't know if we can get those, influenza beta. We can do CD20 treated humans, we already say we're doing that. Actually, it turns out we can get B cell studies, humans, and watch repopulation. That might be sort of, that is CD20. Don't we have any anti-bliss of treated patients? Maybe. But anyway, I was thinking Plaquenil treated patients, that inhibits TLR signaling. So maybe we can try Plaquenil and propose that will, I don't know, that will be reflected in the distortion of this population. But the whole idea will be to show that the heterogeneity in humans, both with and without treatment, or that maybe even the treatment, the heterogeneity at T1 stage can be used as a therapeutic predictor of which treatment might be beneficial. In other words, it's personalized medicine, as it were, the individualized medicine that everybody wants. So that's about it.